What does it really take to discover the origin of life? Not just on a planet, but across the entire solar system. If we could find the right traces, a single discovery could be enough to rewrite our understanding of the universe. But where should we look? There is a small, silent, and forgotten celestial body that might hold an answer. Its name is Ceres. This dwarf planet is an ancient relic wandering through the asteroid belt between Mars and Jupiter. A world of ice and rock, far from sight and speculation, until a mission brought it into the spotlight. In 2007, NASA launched the Dawn probe with the goal of studying two primitive bodies that had remained intact since the primordial chaos of the solar system, Vesta and Ceres. No one expected what would be discovered on Ceres' surface, organic molecules, the raw materials of life. But the real question is, where did they come from? Were they formed on Ceres, or did they arrive from elsewhere? For years, scientists have tried to solve this enigma. Some hypothesize that they were the result of cryovolcanism, where icy volcanoes release materials from the planet's interior. Others argued that these molecules were deposited by asteroids or comets crashing onto the surface. How can such a theory be tested when the available data isn't enough? This is where artificial intelligence comes into play. A team of researchers from the Max Planck Institute for Solar System Research tackled the issue with an innovative method, using AI to deeply analyze the data collected by the Dawn mission. The result was surprising. The organic molecules on Ceres have nothing to do with internal phenomena of the dwarf planet. The evidence indicates that these deposits are primarily located along the edge of the Ernutet crater in Ceres' northern hemisphere. Some are farther away, but none of these sites show signs of cryovolcanic activity. Analyses revealed that the geological signatures are more compatible with an external origin, impacts from asteroids coming from the main belt. But how can an impact preserve such delicate molecules? Computer simulations provided a clear answer. The asteroids hitting Ceres do not arrive at high velocities, and their impact does not generate enough heat to destroy the organic compounds, allowing them to survive. In other words, Ceres has been contaminated from the outside. Its role in this story may not be that of a laboratory of life, but rather an archive, a silent witness to the journey of organic matter through our solar system. However, this does not fully solve the mystery, because another fascinating possibility remains. What if there is still an underground ocean beneath Ceres' icy crust? If that were the case, it might have contributed to the formation of these organic compounds. In 2022, the discovery of saline water molecules in the Urvara crater raised new hypotheses. This suggests that geological activity might still exist beneath Ceres' surface and, possibly, liquid water. Imagine standing on Ceres. The ground is hard and cold, covered by a layer of ice and ancient dust. A lander carefully touches down, extending its robotic arm to collect samples. What if there were still liquid water beneath Ceres' frozen surface? And what if that water contained traces of prebiotic chemistry, similar to those that may have given rise to life on Earth? Scientists know that liquid water is essential for biological processes. On Europa and Enceladus, two icy moons of Jupiter and Saturn, vast underground oceans exist beneath kilometers-thick ice layers. The presence of a subsurface ocean is a key factor in astrobiological research. But Ceres is different. It is smaller, less active, yet has something that makes it unique. It is much closer to Earth than those distant moons. If there really were a hidden ocean beneath its crust, it could be the perfect place to search for clues about the origins of life in our solar system. This leads us to an even bigger question. If Ceres received organic molecules from asteroids and perhaps preserved liquid water beneath its surface, could it be a natural archive of primordial chemistry? But how rare is this phenomenon? Are there other celestial bodies that might have experienced a similar fate? Some scientists hypothesize that organic molecules may be more common than we think. Perhaps the seeds of life have been scattered everywhere in the solar system, transported by comets and asteroids for billions of years. Perhaps the chemistry of life is not an exception, but a widespread possibility, waiting for the right conditions to emerge. Future missions will have the task of answering these questions. NASA and other space agencies are designing new missions to explore the solar system with increasingly advanced instruments. In the not-too-distant future, we may see a probe land on Ceres with the mission to drill deep, analyze the subsurface directly, and search for definitive answers. If we were to discover that liquid water still exists beneath Ceres' icy crust, if we were to find new evidence of organic molecules, it would be another piece in the great puzzle of life's origins. Perhaps not on Ceres, perhaps not even on Earth, but somewhere far away, in the cold silence of the universe, there may be another world that has witnessed the birth of something more than just molecules. With this in mind, the question remains, how close are we to solving the mystery of life's origins in our solar system? And how many more surprises do the worlds we have yet to explore hold for us? Thanks for watching. Leave a like and subscribe to the channel so you don't miss upcoming videos.